Hey all you cool cats and kittens, it's Mr. Key here to give you another chemistry lesson. Oh boy, let's get started. So now I've been fiddling around with some cool things and I've discovered how to get 1080p on my videos. And so that's right, you now have the option to watch this video in glorious 1080p. You should feel lucky. Anyway, looking here we have nuclear reactors, fission nuclear reactors in America. Now there are some on Alaska and Hawaii as well, and this is an older one, but you can see, especially around us in Florida, we have a good amount, and that's because there's a good amount of energy that's needed. But how exactly do these things work? Well, look at this thing in front of you. This is, at least the last time I checked, how these nuclear reactors work, or nuclear power plants work. Basically, what's going on here is you've got a non-radioactive water loop down at the bottom right, and then it takes the water and then you heat it up, and then when you heat it up it causes steam, and that steam moves the turbine. That turbine then causes energy, and the cycle continues over and over and over and over and over and over and over again, and eventually you will have your electricity. Now let me see, I don't have a cursor, but anyway, follow my mouse thing here, and you can see this is where the reaction happens. This is where your energy is coming from, down here, and then whoop, goes into here, and then gives a lot of heat, and that heats up the water, that goes here, does the turbine, and it keeps going back and forth. Now this is basically what they look like. Now you might see something like this. Actually, I have one of these around where I live. It looks like a dome, but it's not actually a nuclear power plant. Usually they have smokestacks like you see on the left here. I used to live not downtown Orlando, but by the actual airport in Orlando, and there were a couple of these guys just chilling out. You can see them in the distance. You know, they're ways off, obviously, and a lot of the nuclear power plants are actually purposefully put a ways away from the towns in case something happens. You can help to minimize the damage. Now, this is what the inside of one of them looks like. Now, this is an older picture, but it's, it shows how much stuff is going on here. I'm hoping within the past couple of years they've learned how to reduce a lot of this stuff and brought in new technologies, but, it is what it is. Now, from here on, to generate electricity, this is what goes on. It says, number one, fission. So a fission reaction is used here, not a fusion. We don't really know how to control that as well yet, even though it is more powerful. Fission reaction heats up the water in a vessel, and the heat is carried away. And so that heat is then, number two, used to heat up water in a second system, which turns into steam. That steam turns a turbine in the generator. And number four, finally, the generator makes electricity. So, if you've ever seen those cartoons before where they have the what is it, like a hamster or a rat, and they're running on the little wheel, and that wheel, powers the generator in whatever you're doing. That's basically what's going on here, but instead of the hamster, that wheel is being turned by the steam. And so the steam comes through, and it's got a lot of force to it. That turns that turbine. That turbine can then give us the opportunity to change that type of energy into electrical energy, which is good for us to use, and pretty much makes everybody happy. And so when we're looking at this, that's what you guys really want to be thinking about here. That's how this happens. We don't actually take the raw energy of nuclear fission. And so there is some energy that's actually lost due to a bunch of things going on at once. But yeah, as far as making electricity goes, we have to change that nuclear energy into something more usable. And that's what we do with the water. Now, here are some pros of nuclear energy. Number one is highly contested, but it is true. No air pollution. All that really happens is we give off a lot of water vapor. The smoke coming out of the smokestack, if you want to call it that, at a nuclear power plant is literally just spitting out water vapor. That's right. You'd think it's some type of crazy chemical or something like that, but no, it is water vapor as far as we can tell and as far as we can test. And water vapor isn't that damaging to the environment. Now, some people say it is. They say it's another greenhouse gas, but, that's a whole other argument for a whole much more, what's the word, qualified person than me. I'm just a science teacher. I'm a good one though. Now, enormous amounts of energy are released, and that's very true. It's the cheapest way to make the most energy, believe it or not. Doing this here, finding fissionable materials, things you can do fission with. It's cheap, it's good, and when you say something is cheap, I guess that's not it's negative, but this is a definite positive here. The cost of electricity would go up a lot more if we had to use something else. Now in Florida, we actually have a legitimate shot at solar energy, but that's not quite the case with a lot of places. Solar energy just isn't where it needs to be. For your house, yeah, that's fine, but we don't have batteries really good enough to hold the charges and things like that. There's a lot going on. Now finally, it's also an alternative to using our rapidly decreasing fossil fuels. So we're not going to have gasoline, we're not going to have fossil fuels, not going to have oil forever. We will probably, actually I'm more than positive we're going to have the things we use for nuclear fission a lot longer than we'll have coal and things like that, because coal is a limited resource. So it's actually a really good resource. Now some people try to argue, and it's just to bring the name of nuclear energy down, that nuclear energy is it's a limited resource, but that's not really true. We have so much fissionable material, and if we can't find it, we can probably make it. That's another really cool part about it as well. And especially if we learn how to do fusion, we're never going to run out of that stuff. So let's keep on going here. Now here are the cons of nuclear energy. Containers of waste products may erode or break. Now this is a definite concern, and whenever you hear claims of people putting nuclear waste into the water, this is what they're talking about. Many times we believe it is unintentional, just to give the people the benefit of the doubt. You should never really blame malicious intent for things that could just be caused by ignorance. That's a big one, ain't it? Anyway, but yeah, containers for waste products may erode or break, which is no bueno, and this would cause massive problems if it leaks into our water. Now, there is also this idea of thermal pollution, heated water return to rivers and things like that. And so, in an ideal world, in ideal systems, in these nuclear power plants, you would actually wait until the water got back to a proper temperature before you put it in the lakes and things like that. But there are cases, and they have found them, where they actually put the hot water back into the river without really letting it cool. Not good. And there's also potential theft of fuel for use in weapons. Now this one's just kind of out there. I don't see this very often being brought up as a point. Maybe it's a much bigger deal than I know, but basically you have your Pu-239 that is very radioactive, and you can use that to create your nuclear weapons, like your nuclear bombs, your fission bombs, your fusion bombs, whatever the case may be. And so that's just something that they're always thinking about, and I guess that is a definite con for nuclear energy, but it's what it is. Let's keep on going. Now, controlled nuclear fusion is a very interesting concept, and here are the pros. And so this is what we want to get to: a very abundant supply of energy worldwide. So we'd have a ton of this, and some people would still, call it a limited resource, but is it really? I don't think so. We're gonna have this stuff not forever, ever, but pretty darn long time, much longer than we'd be alive, or even probably our grandkids would be alive. Now, it's environmentally clean, which is true. If you want to get your eyes open to solar energy and why people say solar energy is kind of dirty, you should see how they make those solar panels, believe it or not. It's very wasteful, gives off a lot of emissions, not good. Number 3, it says no creation of weapons materials, so that's pretty good. And then number 4 says no chance of runaway reactions leading to accidents. Oh wow, that's really great. Now what's the problem? Our cons: it doesn't work yet. That's a pretty big deal. We can't figure it out. So yeah, as awesome as this would be to do fusion, we just can't do it. There was a small meme back when I was younger about learning how to do cold fusion, and changing the world. And that really would change the world, but no, hasn't happened yet. So maybe one of you guys. Hope you guys can figure it out. From here, nuclear fusion. This is a quote from Carl Sagan. This is every time you look up at the sky, every one of those points of light is a reminder that fusion power is extractable from hydrogen and other light elements. And it is an everyday reality throughout the Milky Way galaxy. Now, there's, Carl Sagan. At Christian school, you don't really quote him too much, but he has a definite point here. All of our stars use fusion energy. And so there's a way to do this. We know that. There's a precedent for it. And we've made bombs using nuclear fusion, yet we have not been able to, use it for our real advantage in making energy, which is what we would want. If you hear me sipping, I'm drinking some Cafix. Try Cafix. No caffeine. Good coffee substitute. Now from here, nuclear fusion. Here's some obstacles to nuclear fusion. Obviously, we want this to happen. And, I didn't really look into this today, so maybe they made a breakthrough today. I don't know. Obstacles. It's very hot. Plasma, at least 100 million degrees centigrade. Yikes. That's unfathomable. There's nothing we can possibly think of that could be that hot, realistically. Then from there, high density plasma is another big issue here. It's dense. This stuff is dense. On top of that too, the containment of the plasma would be extremely difficult. We don't really know how to contain it. And then finally, the confinement time. We don't really know. Well, we can do research and we can find out different things to get over all of these things, but we need people to work on this in the future. And the more breakthroughs we have in this, the cheaper energy will become. Hopefully, of course. And the cheaper energy is, who knows, we get a lot of really, really, really cool stuff. Let's continue here. You know what? I think we'll actually stop here. This is another lesson entirely. And you can see here it says rates of decay and half-life. Radionuclides have different stabilities and decay at different rates. This is going to be the start of Monday's episode, and we're going to do some work on radioactive decay, half-lives, and things like that. But I just want to thank you guys for listening in, for looking at these notes with me and going this whole time. I hope you have a wonderful weekend, and goodbye.